will talk about the stoichiometric relations in chemical reactions. We can solve the first question as an example, how to solve these questions. Find the volume of the hydrogen at STP needed to react with 3.55 grams of the chlorine. In order to solve this question, we need first of all to select what are the species needed for this type of reaction, or the question. We can say here, find the volume, so I need the volume of the hydrogen at the STP that can react with 3.55 grams of the chlorine. So the two species here will be the hydrogen and will be the chlorine. So below the hydrogen and the chlorine, I need to write ratio for the hydrogen and I need to write ratio for the chlorine. And these two ratios will be equal. So find the volume of the hydrogen. This is the unknown. So the unknown will be, let's say like x decimeter cube of the hydrogen. This is the unknown. And so below the hydrogen, I will write x, the unknown volume of the hydrogen. And then for the other given, 3.55 grams of the chlorine, it will be just in the ratio for the chlorine, 3.55 grams of the chlorine. So here, the unknown, which is x, and the given, which is that for the chlorine, will be at the same level. Maybe either, both of them, they can be below or upward, it's fine. So the unknown and the given will be at the same level. Then since here, I will start for each ratio alone. Since for the chlorine, we have grams here, the unit upward also will be grams. Since I have here decimeter cube, also here the unit will be decimeter cube. This ratio here at the top, this ratio, this is called the most convenient ratio. And we can get the most convenient ratio depending if we are dealing with mass, if we are dealing with moles, or if we are dealing with volume. So here, to get the most convenient ratio, if I'm talking about moles, then I will deal only with coefficients. If I want the mass, and the mass of course in grams, it will be coefficient times the molar mass. And if we are dealing with volume, which is the decimeter cube, it will be the coefficient times 22.4 decimeter cube. This is at STP conditions. So we have these three main points to find the most convenient ratio. Since here in my question, I want the mass, the grams, and I want the volume, so I will follow this. For the mass, coefficient times molar mass. So since this ratio is for the Cl2, the coefficient here is 1, so it will be 1 times, and the molar mass for the Cl2, Cl is 35.5, so it will be 35.5 times 2, 71 grams per mole. So this will be the molar mass for the Cl2, and I will put the 71 here. So 71 times coefficient 1. This will be the most convenient ratio for the Cl2. For the hydrogen, on the other side, I need to find the volume, which is in decimeter cube. We look at the volume here, it should be coefficient times 22.4. Coefficient of the hydrogen is 1, so 1 times 22.4. So at the end here, I have a ratio, and these ratios are equal. 22.4 over x is equal to 71 over 3.55, and then I want to find x. I can just cross multiply. X is equal to 22.4 times 3.55 divided by 71, and then we can find the answer. Of course, we need to pay attention for the significant figures when I find the answer, and the answer of course will be in decimeter cube. I need to follow the least significant figures. Here I have 3.55, the least significant figures, and also my answer should be carried to 3 significant figures. Okay? So the answer here will be 1.12. It is up to 3 significant figures, and it will be matching the given, so my answer will be right. Question here. So let's read it and let's translate the given into ratio. Find the number of moles of the Fe2O3 iron 3 oxide. So we need the moles of the Fe2O3 produced when 2.8 grams of the iron react with oxygen. Already the reaction is given. So the first thing we do is that I need to specify what are the species needed here. So I need the iron, Fe, iron, and also I need the Fe2O3, iron 3 oxide. So in the reaction here, Fe2O3, I will just write a dash under Fe2O3, a dash under the iron. So these are the 2 species that I need to work with. So these 2 ratios, they should be equal. And then I will start writing down the unknown and the given. As we said, the unknown and the given, they will be to one level. So find the number of moles. I don't know the number of moles. So number of moles here is X. This is the unknown. So below the Fe2O3, this is the X. So X moles of Fe2O3. Since here I have moles, here should be moles. If I continue, find the number of moles, X moles of Fe2O3 produced when 2.8 grams of the iron. So of the iron, I have given 2.8 grams of iron. So the unknown, which is X, and the given, which is 2.8, both of them, they will be at the same level. You can write them down, both downward or upward, it's fine. Then I look at the units, here moles, here grams, here grams. And as we said, the upper numbers here, we get them from the reaction ratio. So this is the most convenient ratio. And in this case, if I want moles, as we said before, for the moles, we look only for coefficients. So if I have mole, and the coefficient here is 2, so the ratio here will be, I will use 2 moles. I want here the grams. So for the moles, as we said, we look only for coefficient. For the mass, it will be coefficient times the molar mass. So in this case, coefficient times molar mass. So coefficient is 4 times the molar mass for iron, which is 56. And in this case, we write 4 times 56. So I have 2 ratios. I have one unknown. I cross multiply to find X. Some students, they do something wrong here. Let's say like they find the value for this ratio, they put the number, they round, and then they find X. In this case, maybe this will affect the final result. So we just put the numbers in one ratio. So even in the calculator, we will use just ratio. The number facing X will be in the downward. So 4 times 56. And then 2.8 times 2. Okay? And then in the calculator, we don't find numbers. We just put fraction and we put all the numbers here. Because if we do rounding in any of the steps, this can affect the final answer. So 2.8 times 2 divide by 4 times 56, and the answer will be 0.02525 moles. The unit is moles. If we look here, we have 2 significant figures. And also here in the given, it's 2 significant figures. We have only one given, 2 significant figures, and my answer should be 2 significant figures. And this is right. So the answer will be 0.025. Question. Find the mass of CH3COH, acetic acid, needed to react with 40 grams of oxygen. It's very important to check whether the reaction first is written or not in the question. If the reaction is written, fine. You need to check whether the reaction is balanced. Maybe here, for example, we don't have any coefficient. Don't take it into granted that the reaction is balanced. We need to balance the reaction if it is not balanced. So, like this reaction, for example, we have coefficient that is already balanced, so it's fine. So the first step will be find the species that we are dealing with. So find the mass of CH3COH. this will be the first species, needed to react with 40 grams of oxygen. Oxygen will be the other species here. So we have acetic acid, CH3COH, and we have the oxygen. Both of them, they are present on the right-hand side. So we write ratio equal ratio. Ratio for the oxygen and ratio also for the acetic acid. Find the mass of the acetic acid. We don't know the mass. This is the unknown. So this is the unknown. And this unknown is X. So I have X grams of CH3COH. Needed to react with 40 grams of oxygen. Oxygen, so the unknown is X. On the same side, we need to put the given 40 grams of the oxygen. So 40 grams will be the given. So given, unknown, they are on the same level. And the unknown is X grams, and the given is 40 grams. So in this case, this will be grams, this will be grams, this is grams, and also this will be grams. So the units in each ratio should be also the same, grams, 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 grams. How can we find the ratio for the reaction ratio? As for the mass, we need, of course, to focus on coefficient times the molar mass. Coefficient times the molar mass. Of course, here for the oxygen, the coefficient is 2. So it will be 2 times, and then we get the molar mass for the oxygen. Molar mass for the oxygen is 16. So 16 times 2, 32. So here I put 2 times 32. So 32 times 2 grams. And then for this one, also to be coefficient times molar mass. Don't forget, the molar mass is the sum of the masses of all the atoms present in this molecule. So here, if I want to get the molar mass for the acetic acid, I have 1 carbon 12 plus hydrogen is 1, so 3 times 1 plus 3, then another carbon plus 12 plus 16 plus 16 plus 1. So I need to add the masses of all the atoms. And if we add them, we'll get 60 grams. So now I have ratio. 60 grams, 60 over X is equal to 2 times 32 divided by 40. To find X, in one step only, I will use the ratio, I will use the fraction on the calculator. So I put X is equal, I put fraction, any number facing X, okay, here as if it is X over 1, will be downwards, so 32 times 2, and then the other numbers will be 40 times 60. Even if I don't have a calculator, I can simplify and then find the answer. So on the calculator here, we just put 40 times 60, divide by 32 times 2, and the answer will be 37.5 grams. If we look here, my answer is 3 significant figures, and the given is 2 significant figures. So therefore, I should round my answer to the correct number of significant figures, which will be 2. So here, if I have 3 significant figures, then I need to round it to 2 significant figures. 2 significant figures, I will choose 2 numbers, and then I will look at this number. This number is 5 or more, so I will add 1 to 7. So here in this case, it will be rounded to 38 grams. And here, we need to find the mass of the water produced when 35 grams of C5H10 burns in the oxygen. Of course here, we need to double check that the reaction is balanced first. So check if the reaction is balanced. You need to know what are the 2 species involved in the question. You need to know the given, you need to know the unknown, and then you need to know how to write down the most convenient ratio. So these are the 5 main steps. And then at the end, you need to figure out how many significant figures your answer should be. So the first thing, we look at the reaction. The reaction is balanced. So balanced reaction This is fine. Then, unknown and the given. Find the mass of the water produced. I don't know the mass of the water. So the mass of the water will be my unknown. So this is x, and since the mass will be in grams, so it's x grams. So this is my unknown. Unknown is x grams of the water. Produced when 35 grams of C5H10, so 35 grams of C5H10, this will be my given. So the reaction is balanced. I know the unknown, 35 grams of C5H10, this will be my given, and then I need to look at the reaction. So what are the species involved here? The species involved will be water and C5H10. So below the C5H10, I will draw a line. Below the water, I will draw a line. This ratio will be for the water, this ratio will be for C5H10 as we said, and these two ratios are equal. I need to place now the unknown and the given. Unknown and given will be placed on the same side, or on the same level. So find the mass of the water. I don't know the mass of the water. X grams of water. 35 grams of C5H10. So in this case, the 35 grams, which is the given, will be on the same level with the unknown. So X grams here, C5H10, 35 grams. So every 35 grams will give X grams of water. And then I need to write the same unit. Grams here, grams here. Grams and grams. How can I find the most convenient ratio? To find the most convenient ratio, I need to multiply the coefficient times the molar mass. Coefficient times the molar mass. Usually a common mistake done by the students, they don't know how to find the molar mass if they have the coefficient. And for example, I have many students, when they want to find the molar mass for 10 H2O, what they do is 10 H2O. They multiply 10 by 2 first. Of course, the hydrogen is 1 and oxygen is 16. So here they have 20 hydrogens. So it will be 20 times 1, 20. And then they add directly 16. And their answer is 36. They didn't multiply 10 with the oxygen. And of course, this is wrong. So please, you need to pay attention. To get the molar mass times coefficient, the correct answer here will be 10 times H2O. As if H2O is present in the bracket here. So 10 times, and then the molar mass for the hydrogen is 2. So 2 times 1, 2. Plus 16, so it's 10 times 18, which is 180 grams. So the molar mass for water is 18, times 10 moles, I have 180 grams. So the correct answer here should be always 10, multiply 10, and then 10 as a coefficient multiplied by the molar mass for 1 mole, H2O, 2 plus 16, which will be 18. So please pay attention for this mistake. Same thing here, we need to find the molar mass times the coefficient. So in this case, I will put 2, which is the coefficient, times the molar mass. What's the molar mass? C5H10. So in this case, C5, 12 times 5, 12 times 5, plus 10 times 1, plus 10. So 12 times 5, 60, plus 10 will be 70, so I put 70. So now I have 2 times 70 over 35. This will be equal to the other ratio. Cross multiply, I can find x. As I told you here, you need also to put the answer as one ratio, as one fraction. So in the calculator, you will choose the fraction. Any number, cross multiplication, 35 times 10 times 18 divided by 2 times 70. Okay? Even if you don't have calculators, you can do this, you can simplify, you can get the answer. It's easy. And this is equal. Then I put the numbers 35 times 10 times 18 divided by 2 times 70, and then the answer will be 45. So 45 grams. I need to write down the answer to the correct number of significant figures. And here, if I look at the given is 35, 2 significant figures. Also here, it's 2 significant figures. So it's fine, I don't need to round. So my final answer will be 45 grams. Here, we have other type of ratios. We have heat with something else. So in this case, find the heat produced, and we can deal with heat as if it is one of the speeches in this reaction. So find the heat produced when 1 gram of hydrogen reacts with oxygen. As we said, the first thing, we need to find whether the reaction is balanced or not, and whether the amount of the energy is written also right. So let's say like here in this equation, we have 2 hydrogens plus 1 oxygen to give 2 water to steam plus 5, 6, 8 kilojoules. Sometimes here, this amount of energy is not given in the reaction. It's given as per mole. For example, they can tell you that it's 284 kilojoules per mole hydrogen. So we need to pay attention to the unit, because here 284 kilojoule per mole hydrogen, and in my reaction I have 2 hydrogens. So in this case I need to multiply the 284 by 2, and that will be 568 kilojoules. So this is a very important point to pay attention for the heat, for the kilojoules, whether it is mentioned in the reaction itself, it's fine, or it is mentioned as kilojoule per mole, any of the species in the reaction. So we write the correct amount of heat in the reaction, and then we proceed normally. Find the heat, so the heat is the unknown. Find the heat is the unknown, and this will be the x. So we need to specify what are the 2 species here. Find the heat, which is unknown is x, produced when 1 gram of hydrogen. The other given here is 1 gram of the hydrogen, so this will be the given. Okay, so unknown and given. And as we said, unknown and given should be written on the same level, both of them. So I am dealing with heat. I will write a line below the heat, and I'm dealing with hydrogen. So I have hydrogen, I have heat. These 2 ratios are equal. And then let's translate what's given here in the reaction ratio. Find the heat produced. I don't know the heat. Find the heat. X kilojoules. X kilojoules. Kilojoules here, the same unit, kilojoules. Okay? 1 gram of the hydrogen. The given and the unknown on one level. So the given will be 1 grams of the hydrogen. Here grams, here also grams. How can I find the most convenient ratio? For the heat, it will be the same number in the reaction. It's 568 kilojoules. For the grams, as we said, to find the mass, it will be the coefficient times the molar mass. So when we say coefficient is 2. And what's the molar mass for the hydrogen? Hydrogen is 1. So 1 times 2, 2. So 2 times 2 grams. I have a ratio now. 4 over 1 equals 568 divided by x. To find x, as we said, always we write all the numbers in one ratio in order not to round in every step, and this will affect our final answer. So here x, I need to find x, which will be 1 times 568, and then divided by 4. So 568 divided by 4, and the answer will be 142 kilojoules. 142 kilojoules. Did I finish here? No, I didn't finish. I need to check the correct number of significant figures. Here in the given, it's 3 significant figures. And since we have only 1 given, then my answer also should be related to this given. Also here, if I look at my answer, it's 3 significant figures. So they match, I don't need to round, and this will be the final answer, 142 kilojoules. Question number 6 here, we need to find the mass of the C4H10, which is butane, which burns with 2.6 moles of the oxygen. And of course the relative atomic masses are given here and the reaction is given. So first of all, the reaction is balanced. I have no problem with the reaction. So I need to specify the unknown and also I need to specify the given. So find the mass of C4H10. The mass here is X, unknown. So this is my unknown. Find the mass. This is the unknown and this will be in grams. So find the mass, X grams, of C4H10, which burns with 2.6 moles of oxygen. 2.6 moles. This is the given. 2.6 moles of oxygen. This is the given. So I am dealing with oxygen. I'm dealing with C4H10. If we look at this reaction, C4H10, I write ratio. Oxygen, I write another ratio. So one ratio will be for oxygen, one ratio will be for C4H10, butane. So here, find the mass. I don't know the mass of butane, C4H10. So in this case, I need to place X below the C4H10. So I put X, find the mass, X grams. Grams here, X grams, which will burn with 2.6 moles of oxygen. For oxygen, 2.6 moles. So below oxygen, I will write moles. And this is the given, 2.6 moles. So again here, I will repeat, unknown and given, they are on one side. Both of them can be downward. Both of them, they can be upward. It's fine. So X grams of C4H10 will react with 2.6 moles of the oxygen. Then we look at the units. Grams here, grams here. Mole here, also I need to write mole here. And to find, let's say like the most convenient ratio, I'll repeat this. To find the moles, I will look only at coefficient. To find the mass, which is in grams, it will be coefficient times the molar mass. So here I have mole. In the moles, I will look only at the coefficient. It's for oxygen, 13. So I will write 13 moles. For the grams, which is the mass, it will be the molar mass times coefficient. So it will be 2 times. And what will be the molar mass here? I can get the molar mass. C4H10, it's the sum of the masses of all the elements. So C4H10, 12 times 4. 12 times 4. Plus, this is the mass for the C4, 12 times 4. I have 10 hydrogens, plus 10 times 1, which is 10. Okay? So in this case, 12 times 4, plus 10, and the answer will be 58. So in this case, I have ratio 2 times 58 over X equal to 13 over 2.6. To find X is equal, as I told you. Don't, let's say, like, solve each ratio alone, and then you will round, and then you will find your final answer. Just put all the numbers at once, in one fraction, in one ratio, and then you can find it only in one step. So X is equal to 2 times 58 times 2.6, and then divided by 13. If some student, they don't know how to write this ratio, just, you can add one more step, okay? You can cross multiply, it will be 13x equals to 2.6 times 2 times 58. You want x, so you want to get rid of the 13, you divide by 13 here, you divide by 13 here, and then we'll get the same ratio. And this is equal to 2 times 58 times 2.6 divide by 13. We will get 23.2, and the unit is grams, 23.2 grams. If we look at my answer here, my answer is 3 significant figures, which is not the case for the given, because the given is 2 significant figures. So I need to round my last answer here. So I will take two numbers as two significant figures. Then I will look here at the 2. The 2 is less than 5. Nothing will change. So the answer will be 23 grams. So now I have two significant figures, and this will be the final answer. In question number 7, find the heat produced when 0.025 moles of the hydrogen reacts with oxygen. Again here, we have heat. We need to look at the heat, whether it is present in the reaction or not. And we need to select the species that will be involved in the reaction. Find the heat produced. So first, find the heat produced. This will be my unknown. So the unknown here is x kilojoules of the heat. I'm dealing with the heat. When 0.025 moles of hydrogen. So hydrogen is the other species. So I have ratio between heat and hydrogen. 0.025 moles, this will be here my given. So I have unknown, I have given, okay, heat and hydrogen. So I will look at the reaction. We have heat here. I write ratio. And for the hydrogen, there should be a ratio. These two ratios are equal for the hydrogen and for the heat. If these ratios are equal, let's put the x, the unknown, find the heat. I don't know the heat. So below the heat, we write x kilojoule. This is my unknown. Unknown and given, they should be at the same level, as we said. So when 0.025 moles of hydrogen, this is the given. Below hydrogen, I will write 0.025 moles of the hydrogen. Okay? So I have the unknown, I have the given, hydrogen, heat. We should use the same unit in the same ratio here. So kilojoules, kilojoules. Moles, moles. So how can we find the most convenient ratio or the reaction ratio here? Kilojoules will be the same as present in the reaction, 568. So this is 568 kilojoules. And for the moles, I need to write just the coefficient. Coefficient for the hydrogen is 2. So I will just write 2. So I have 2 divided by 0.025 equals to 568 over x. I want to find x. I cross multiply. 2x, 2 times x, 2x, is equal to 568 times 0.025. If I want to find x, I divide by 2 here, I divide by 2 here. And again here, x is equal. I will use just one ratio in the calculator. So x, I will just put the fraction, and I put all the numbers, 568 times 0.025, and then divided by 2, and I will get 7.1. So here 568 times 0.025, we divide by 2 already, and the answer is 7.1 what? Kilojoules. Kilojoules. I need to look, of course, at my given to what significant figures. I have 0.025, which is two significant figures here. My answer at the end, 7.1 kilojoules, is also two significant figures. So my answer is right, there's no need to round. So the answer is 7.1 kilojoules. In question 8 here, we need to write down the reaction. Balance the equation of burning C3H6 with oxygen to give H2O and CO2. Of course, if we burn any organic compound containing carbon with oxygen, the products will be carbon dioxide and water vapor. So if we we need to write down the reaction. C3H6 will burn, of course it will burn with oxygen. So C3H6 will burn with oxygen. It will react with oxygen. To give what are the products? H2O and CO2. In all reactions, including carbon, hydrogen, oxygen, it's very important to start with the carbon first, then hydrogen, then oxygen. So I need to balance first carbon, then I need to balance the hydrogen, then I need to balance the oxygen. If we look at carbon here, I have 3 carbons. 3 carbons, C3, 3 carbons. And on the product side here, I have only 1 carbon. So to make balancing for the carbon, I need to multiply by 3. So I have 3 CO2 now. 3 carbons, 3 carbons, the carbon is balanced, it's fine. For the hydrogen, hydrogen here is 6 hydrogens. 6 atoms of hydrogen are present. Also here, I have 2. So to make the number of atoms of the hydrogen equal on both sides, I need to multiply by 3. So now I have 6 atoms of hydrogen on both sides. Why we're doing this? Because atoms, we know that atoms are conserved. In any chemical reaction, atoms are conserved. So the number of the atoms of each type and the total atoms on the reactant side will be equal to that on the product side. So here, hydrogen, 6 hydrogens, 6 hydrogens. Hydrogen now is balanced. So I have 3 carbons. I have also 3 carbons, they are the same. I have 6 hydrogens, 6 hydrogens, same. What will be left is only oxygen. I will start oxygen on the product side now. 3 CO2. If I just hide the 3 now, CO2 has 2 oxygen atoms in every 1 molecule. But in 3 molecules, so this 3 belongs to the C, and this 3 belongs to the O2, to the oxygen. So as if I have 3 bracket and then CO2 inside. This 3 will be for both. So I have 6 oxygens, here 6 oxygens, and here 3 times 1, I have 3 oxygens. So 6 and 3, it will be 9. But what will be the number here that I multiply by 2 to give 9? So the answer will be 9. 9 over 2. 9 over 2 times 2 is equal to 9. Okay? I can keep the balancing like this by using a fraction. But if I want to use the smallest whole number, okay? So in this case, I need to multiply the whole equation by 2. So if I multiply the whole equation by 2, it will be 2C3H6 plus 9O2 to give 6H2O plus 6 CO2. Again here, if I just check whether the reaction is balanced or not, 6 carbons, 2 times 3, 6 carbons, 6 carbons here, 2 times 6, 12 hydrogens, 12 hydrogens. I have here 18 oxygens, 6 O, 6, and the 12, I have 18. So both reactions are right, this is right, and this is also right. In question number 9, we need also here to find the moles of the CO2 when 0.1 mole of C2H6 burn with oxygen. As we said, we need to check first if the reaction is balanced. The reaction is given, the reaction is balanced. I need to find given and then find the moles of the CO2. Moles of the CO2. For the moles, this is the unknown. I don't know the moles, so this will be X. When 0.1 mole of C2H6, this will be the given. So I have given, I have unknown, and then we select the species that I will deal with. I will deal with C2H6 and also with the CO2. Okay? So from the reaction here, I want to deal with CO2. I will just draw a line below CO2. I want to deal with C2H6, a line below C2H6. These ratios on both sides, they need to be equal. And then I need to write down the unknown and the given. Unknown given to one side, find the moles of the CO2. I don't know the moles of the CO2, so this is X moles. When 0.1 mole of the C2H6, this is the given, 0.1 mole of C2H6. So unknown, given to one side. If this is mole, this will be mole. If this is mole, also this will be mole. Simple, if I want to find the most convenient ratio here, I need just to use the coefficient. So if I want to use the ratio, I will use only the coefficient. Coefficient for the CO2 is 4, coefficient for C2H6 is 2. Every 2 will give 4. Every 0.1, again 0.1 times 4 divided by 2, and the answer will be 0.2. So x is equal to 0.1 times 4 divided by 2, and the answer will be 0.2. I need to pay attention here. 0.2 is one significant figure, while here 0.10, this is two significant figures. So I need, of course, to adjust my answer. It should be 0.20 moles, and then now my final answer is to two significant figures, and it will match the given, and it will be okay. In question number 10 here, we need to find the volume of the air at STP. So find the volume of the air at the STP needed to burn 0.2 moles of C2H6. As we can see here, we don't have any air in the reaction. So what ratio we can select here? It's very important to recall that air approximately is made up of 80% nitrogen and 20% oxygen. So if I want to find relation between oxygen and the air, we can say that volume of oxygen is 20%, 20 over 100 over volume of the air. If I divide by 20 here, it will be volume of the air divided by 5. So in this case, I can say that volume of the air is equal to 5 times volume of the oxygen. So volume of the air is equal to 5 times the volume of the oxygen. Since I want to find volume of the air, so volume of the air here is unknown, I want to find it. I need first to find volume of oxygen, because in the reaction here I have oxygen. And the 0.2 mole, this will be given of C2H6. So now I need ratio between C2H6, which is given, and the oxygen, where I need to determine the volume of the oxygen first, and then I can apply it to get the volume of the air. So here, if I need C2H6, I will draw a line below C2H6 to get ratio for this and for the oxygen, and these two ratios are equal. Find the volume of air. As we said, we need to find first volume of the oxygen. How can I find volume of oxygen? It's x decimeter cube. This is the unknown. I want to find volume of the oxygen. Needed at STP, of course, STP, as I said before, every 1 mole of a gas at STP conditions has a volume of 22.4 decimeter cube. Okay, so here, x decimeter cube. The given is for C2H6. Given and unknown, they are at the same level. So here I have 0.2 mole. If here I have mole, then the unit at the top will be mole. If here I have decimeter cube, then also at the top it will be decimeter cube. To get the most convenient ratio for the moles, we look only at coefficient. So the coefficient for C2H6 is 2. I will write 2. To get the volume for the oxygen, it will be coefficient times 22.4. So to get the ratio here, it will be 7 times 22.4. This x here will be the volume of the oxygen. So volume of oxygen is equal to 0.2 times 7 times 22.4 divided by 2. And if I want to get the answer, as I said, one step, I put a fraction in my calculator, I put all the numbers at once, 0.2 times 7 times 22.4 divide by 2. The answer will be 15.68 decimeter cube. Don't round here because this is not our final answer. I need to find volume of the air. To find volume of the air, I can also use this relation directly. So I can say that volume of the air is equal to 5 times the volume of the oxygen. So in this case, volume of the air will be 5 times the volume that already calculated. It will be 15.68. So 15.68 times 5, and the answer will be 78.4. So this will be volume of the air, 78.4 decimeter cube. My answer here is 3 significant figures. If I look at the given also 0.200 is 3 significant figures. So they are matching. So my answer will be to 3 significant figures, and it will be right in this case. In question 11, we need to find the volume of the nitrogen gas formed at STP when 3.2 grams of oxygen reacts with N2H4. As we said here, we need first to specify what will be the unknown and what will be the given. Find the volume of the nitrogen. I don't know the volume, so this will be my unknown. This is X of nitrogen. This is my first species that I will deal with, nitrogen, formed at STP when 3.2 grams of oxygen. 3.2 grams of oxygen. Oxygen will be the second species I will deal with, and this will be my given. So, in the reaction, I will choose oxygen as one of the species here. I will just draw a line below oxygen. And I want also N2. Below N2, I will also draw a line. And these two ratios for both species should be equal. Find the volume of the nitrogen. Volume of the nitrogen. I don't know the volume of the nitrogen, so this will be X. X decimeter cube. 3.2 grams of oxygen. 3.2 grams of oxygen, where the unknown and the given, they are at the same level as we said before. So decimeter cube here, then we check the units. Decimeter cube, here it should be decimeter cube. Here grams, also here grams. But how can I find the ratio, the most convenient ratio here at the top? As we said before, for the grams, it will be coefficient times the molar mass. If I want to find for the decimeter cube, it will be coefficient times 22.4. Why I'm using 22.4 here? Because I'm working at STP conditions. If I'm working, for example, at RTP, I will use 24 instead of 22.4. But here it's STP only, STP conditions. So I will use the 22.4. So to get the ratio here, for oxygen, it's only 1. So coefficient times the molar mass. Coefficient is 1. So the molar mass for oxygen, 16 times 2. 2 oxygens, 32. So it will be simply 1 times 32, which is 32 grams. If I look at the nitrogen, also here the coefficient is 1. So to find the volume, it will be coefficient times 22.4, which is 1 times 22.4, and then the number here will be 22.4. So now my ratio is ready. 32 divided by 3.2 is equal to 22.4 over X. So to find the volume of the nitrogen X, it will be equal to 3.2 times 22.4 divided by 32. You can solve it directly. If you want, you can put the numbers on the calculator. 3.2 times 22.4 divided by 32, and then the answer is 2.24. 2.24 decimeter cube. If I look at my answer here, I have 3 significant figures. But this will not match the given, because in the given here, I have 2 significant figures. So I need to do the rounding. To do the rounding, I will take only 2 numbers for 2 significant figures. 2 numbers for 2 significant figures. And then I will stop here. I will look. This 4 is less than 5. So nothing will happen. So I will round it to 2.2 decimeter cube. And this will be the final answer for the volume of the nitrogen. In question number 12, find the moles of the CH4 needed to react with 44.8 liters of oxygen at STP. Of course, don't forget that liters is the same thing as deciliter cube. Again here, we need to check the reaction, check if it is balanced. The reaction is written, we have coefficients, so it is balanced. I need to check unknown and also the given. Find the moles. I don't know the moles, so this is the X. So this is my unknown. But of which species? Of CH4. So I have unknown of CH4. Needed to react with 44.8 liters. 44.8 liters, this is the given. And of which species? Of O2 at STP. So I have now CH4, I have O2, so I need CH4 and O2 only in this reaction. So I write ratio for the CH4, I write ratio for the oxygen. And in this case, find the moles of CH4. I don't know the moles, this will be X. So below the CH4, I will write X moles. And the given 44.8 liters will be matching the unknown, as we said. Unknown and given, they should be at the same level, both of them. Downward, upward, it's fine. So X moles with 44.8 liters of oxygen. If here I have mole, then the upper unit will be mole. If here I have liters, the upper unit will be liters. How can we find the mole here? We just look at the coefficient. So to find the moles, we look at the coefficient. Coefficient is 1, so I will write 1 mole. Here, to find the liters, to find the volume, it will be coefficient. So here, I will look only at the coefficient. Here, I need to look at coefficient times 22.4 because it's at STP conditions. So here it will be 2 times 22.4. If we look here at this ratio, everyone will give 2 times 22.4, which means everyone will give 44.8. Here also we have 44.8. It's the same thing. We don't need to make the calculation here. Everyone will give 44.8. So 44.8 will give, or will react with X. So X here is 1. So the answer will be 1 mole. I write the answer as 1.00 because I need 3 significant figures matching the given, because the given also here is a 3 significant figures. In question number 13, we need to find the mass of C5H12. Again here, we look at the reaction, we have the reaction, it is balanced. We focus on the unknown and the given. So find the mass of C5H10. I don't know the mass, so this will be the unknown. And this will be the X. Of C5H10, this will be my first species here. That reacts with 30 moles of oxygen. Oxygen will be my second species, and 30 moles will be the given. And don't forget here that the given is 3 significant figures. So my answer at the end should be 3 significant figures. Find the mass of C5H10. So the first species will be C5H10. I will draw a line below C5H10. The second species is O2. I will draw a line under O2. These 2 ratios are equal. Ratio for oxygen and ratio for C5H10. Find the mass of C5H10. I don't know the mass. So the mass is X. X what? X grams. This is the mass. X grams of C5H12. That reacts with the given unknown. Reacts with a certain given of oxygen. The given is 30 moles. So the given and the unknown are to one side. And then I double check the unit. Moles here, I need to use mole here for the oxygen. Grams here, also I will use grams here for C5H10. To get the most convenient ratios, the number that are present at the top here from the reaction ratio, for the moles, I will look only at the coefficient. Okay? For the mass,
it will be the coefficient times the molar mass. So for the moles here, I will look only at coefficients, which is 15, 15O2, just 15. For the mass, grams, coefficient times molar mass. So it should be 2 times, and I need to find the molar mass. The molar mass here for C5H10, C5H10, 12 carbon, 12 is the relative atomic mass of the carbon. So 12 times 5 plus hydrogen is 1. So 1 times 10, which is 10. Okay, so 12 times 5, 60, plus 10, 70. So 2 times 70. So I have ratio now, 2 times 70 over x equals 15 over 30. So we cross multiply both sides. If we multiply 15 times x, we'll be having 15x. I want only x, so I need to divide by 15. So 15 will be in the denominator, so 15. And then 2 times 70 times 30. We can solve it also again. 30 here, divide by 15, we have 2, divide by 15, we have 1. And then we have 2 times 2, 4. 4 times 70, which will be 280. So the answer will be 280 grams. If we look here, I have 3 significant figures as given. And then also here, my answer will be 3 significant figures. Okay, so they will be matching. There's no need to make the rounding. In question 14, we need to find the moles of the KCl. The reaction is given, it is balanced, fine. Find the moles of the KCl. I don't know the moles, so this will be x. This will be my unknown of KCl, formed when 7.1 grams of Cl2, 7.1 grams, this will be the given. And Cl2 will be my other species. And don't forget that this given is 2 significant figures. So my answer at the end should be 2 significant figures. Again here, let's match. We need to write down what are the species included. So find the moles of KCl. So below KCl, I will draw a line. I don't know. I want ratio of the KCl. I don't know the KCl. And I want also Cl2. So KCl, Cl2 are the 2 species. So below KCl, I will draw a line. Below Cl2, I will draw a line. And these 2 ratios are equal. So let's translate the given and the unknown. Given and unknown to one side, or to one level. Find the moles of KCl. I don't know the moles of KCl. So X moles. Form 7.1 grams of the chlorine. This will be the given. Unknown, given, okay, to one level. So 7.1 grams of the Cl2. Here mole, here I will use mole. Here grams, here I will use grams. Again, I will repeat. To find the moles, I will look only at coefficient. To find the mass, to find the grams, I will look at the coefficient times the molar mass. So, for the moles here, only coefficient. For the KCl, it will be 2. For the grams, for the Cl2, it will be coefficient times molar mass. You are lucky here, coefficient is 1. So 1 times the molar mass. We know that Cl is 35.5. So to get the molar mass, it's 35.5 times 2, which will be 71 grams. So 71 grams here times 1, which will not affect the answer. So 71 grams will be the molar mass of Cl2. So 71 will give 2. 7.1 will give what? Will give 0.2. So even we don't need to make the calculation by using the calculator. So 0.2. But don't forget that the given is 2 significant figures. And my answer should be the 2 significant figures. So the answer should be, the final answer is 0.2, 0, and then we put the unit, which is mole. So 0.20. In question 15 here, we need to find the volume of the oxygen needed to react with 0.8 moles of C2H6.
Again, the process is the same. We need to check whether the reaction is balanced or not. The reaction is given, the reaction is balanced. So my main focus here is to find the unknown and the given. Find the volume of the oxygen. I don't know the volume, I need to find it. So this will be my unknown, and this is X. The species that I will be dealing with is O2. Find the volume of oxygen. Needed to react with 0.8 moles of C2H6. 0.8 moles, this is given. And this given is a 3 significant figures. 0.800 moles of C2H6. So the other species here will be C2H6. So I am dealing now with oxygen and C2H6. So below oxygen, below C2H6, I need to have ratios. Ratio for the C2H6, which will be equal to the ratio of the oxygen. So if I translate now what's written in the question here, find the volume of oxygen. I don't know, this is X. X decimeter cube of O2. Needed to react with 0.8 moles of the C2H6, so 0.8 moles of C2H6, given, unknown, they are to one side, or to one level. So here, and then I will write down the same unit. In the same ratio here for oxygen, I need to use the same units. Decimeter cube, decimeter cube. Mole here, mole here. How can we find the ratio, the reaction ratio here? The reaction ratio should be by using moles, by using only the coefficient. And for the volume, it will be coefficient times 22.4 because I'll be dealing at STP conditions. Here it's not mentioned, but it should be mentioned whether STP or RTP. If it is STP, I will use the 22.4. If it is RTP, I will use the 24. Since in most cases here we are using the STP, so let's focus on the 22.4. If I want to find these numbers, to get them all, I need only to write down the coefficient. So it's 2. To get the decimeter cube, which is the volume for the oxygen, it will be 7 times 22.4. Okay? So here, every 2 will react with 7 times 22.4. This from the reaction ratio. Every given 0.8 will react with X. So to find X, it will be 0.8 times 7 times 22.4 divided by 2. Okay? So to find the answer here, 0.8 times 7 times 22.4 divided by 2, the answer will be 62.72 decimeter cube. If you look here, the answer is 4 significant figures, while in the given it's 3 significant figures. So I need to round here. So to round the final answer into 3 significant figures, I will choose the first 3 numbers, and then I will look at the 2. The 2 here is 5 and below. So I need to just delete it, cancel it, and the final answer will be 62.7 decimeter cube. 3 significant figures. In question 16 here, we can see that we have no reaction. So we need to write down the reaction, and we need to translate the given so that we can solve the question. Find the heat released when 73 grams of HCl are produced from its elements. So if we want to write down the reaction, HCl are produced, means they are formed. They are on the product side. So HCl will be formed from the elements. What are the elements that can form HCl? Hydrogen and chlorine. But hydrogen exists in nature as H2, so it will be H2 plus the chlorine, which is Cl2. So H2 plus Cl2 to balance here, we need to put 2, it will be 2 HCl.
So find the heat released, so we need some energy here, when 73 grams of HCl, so I need HCl, so I will draw just a line under HCl, are produced from its elements, given that delta H is equal to minus 185 kilojoule per mole hydrogen. As I told you before, we need to pay attention to the unit of the heat if it is given. Here, since it's negative, delta H is negative, this means it will be exothermic. And already here it is mentioned that the heat is released. It's exothermic. So we need to add the energy on the product side. So plus here, 185 kilojoules, it's per mole hydrogen. So it's very important to focus on the mole hydrogen, per mole hydrogen. So for every 1 mole hydrogen that is present in the reaction, we have 185 kilojoules that will be released. Then I will look at my balanced equation. I have 1 hydrogen. So this value for the heat is right to place it like this, 185, without changing it. Okay? So the reaction will be H2 plus Cl2 to give 2 HCl plus 185 kilojoules. The species that was needed here, HCl. So I put a line under HCl. The other unknown, find the heat. So this heat is unknown. And this will be my X. So I will write a line below the heat, because this is what I need to find. And these two ratios are equal. So X kilojoules, this is the unknown, when 73 grams. 73 grams, this of course the given. Given of the HCl. Given and unknown, they will be to one level. So 73.0 grams, this is the mass for the HCl, this is the given. X kilojoules, grams, kilojoules here, and here I will write the same number present in the reaction, 185. Grams here, grams here. Of course, to get the grams, as we said earlier, to get the grams, the ratio, for the ratio, it will be coefficient times the molar mass. So it will be 2 times, and what will be the molar mass here? Hydrogen is 1, and Cl is 35.5. So the molar mass will be 36.5. So it will be 2 times 36.5. If we just simply multiply 2 times 36.5, we will get 73. 73 will give grams, will give 185 kilojoules. 73 grams will give what? It's the same amount. It's 185 kilojoules. So 185 kilojoules. The answer here is the 3 significant figures. If we look at the given, also it's 3 significant figures. So they are matching, it's fine. I need my answer to be 3 significant figures, matching the given. So the answer is right.
Another question here, question 17. We need to find the moles of the NO2. So find the moles of the NO2. How many moles of the NO2 formed at STP when 2.24 liters of NO, 2.24 liters of NO are reacted with 8 grams of water. Sorry, it should be oxygen here. So 80 grams of oxygen. Okay, so we have 8 grams of oxygen. If we look here, this is the first question here, where we have 2 given for 2 reactants. I have given for the NO, I have given for the oxygen. So how can we solve this question? Which given I will choose to find the number of moles for the NO2? Of course, in this case, when we have 2 given for 2 reactants, we need to solve it by using excess and limiting. Okay? So whenever we have 2 given for 2 reactants, it should be by using excess and limiting technique. Excess and limiting, of course, I will list
the steps for this technique. So excess and limiting will be used only if we have two givens for two reactants. So it will be excess and limiting. The first step that you will do, you will find the number of moles. We have many ways to find excess and limiting. I think this will be the easiest. Find the number of moles. Second, divide by coefficient. And third, I will compare. The larger one, the larger number, will be the excess, and the smaller will be the limiting. And the fourth step, I will use the given of the limiting for the calculation. You need to know these steps before you apply any excess and limiting technique, okay? So we apply excess and limiting when we have two given for two reactants. This is the first thing. How can we apply it? We find the number of moles for each one. We divide by coefficient. We compare. The larger one will be the excess, the smaller one will be the limiting, and we use the given of the limiting for the calculation. So let's move step by step. How can we find the moles? In order to find the moles, it depends on the given. Here, for example, I have volume at STP. Here I have grams. I can have, for example, we can have moles. So we need to find the number of moles first. If we have volume, to find the number of moles is equal to volume over 22.4 in liters or decimeter cube. Okay? So this is at STP. So to find the number of moles here, it will be the volume, which is 2.24, divided by 22.4 liter, it's fine. So the answer will be 0.1 moles. So the number of moles is 0.1. To find the number of moles for the second, number of moles here for the oxygen, and it's better than the exam. In the written part, for example, if you write it down in this way, number of moles here will be mass over molar mass, because I have the mass, so it's easier. So 8 divided by the molar mass, which is 32. So 8 divided by 32, we will get 0.25. So the number of moles will be 0.25 moles. So I have 0.1 moles of NO, 0.25 moles of O2. So this will be the first step. The first step is done. I need to divide by the coefficient. I will take the 0.1, I divide by 2. So the answer will be 0.05. Here, 0.25, I divide by 1, it will be 0.25. So already I have divided by the coefficient, so this will be a second step done. Then I will compare these two numbers. The larger one, which is the oxygen, this will be the excess. So oxygen will be in excess and NO will be the limiting. So this is the first step here, to find excess and limiting. Why I want to do the excess and limiting? In order to use the given of the limiting for the calculation. So I need now to find the number of moles of the NO2. Since oxygen is in excess, as if oxygen is not there, I will use only the NO. So now I want ratio between NO and NO2. Okay, so I will erase this. So these steps, find moles, divide by coefficient, we compare, and then we use the given of the limiting. So now I will use the given of the limiting to find the moles for the NO2. Okay, so I will take ratio between the limiting, which is NO, with NO2. And again, the same thing here, 2, 2. I can cancel the 2, it's fine. I can keep it also, it's fine. So I want relation between the limiting, okay, with the moles of the NO2, which will be the unknown. So now the moles of the NO2 is the unknown. And this will be X moles of NO2. So what was given? 2.24 liters of NO and 8 grams of the oxygen. Since oxygen is the excess, I will not use it. I will use the NO, which is 2.24 liters of the NO. So 2.24 given, unknown, here mole, and here liters. To get the moles here for the ratio, to be only by using the coefficient, so only 2. To get here the liters, to be 2 times 22.4. I can just find X. If you want, you can cancel this 2 with this 2. It's fine. So X is equal to what? To 2.24 over 22.4. And the answer will be 0.1 moles. If I look here at the given is 8 grams of oxygen and 2.24 liters. Even though here in the limiting, I used the 2.24, which is the 3 significant figures. But of course, when these two react together, the reacted amount, of course, will be affected by the least significant figures. And O2 here is 2 significant figures, 8 grams, 8.0. So we have 2 significant figures here. So the amount that will be reacting also will be 2 significant figures. And that's why here the final answer should be 2 significant figures. Even though I have used the 3 significant figures of the limiting reagent. But when they react, the reacted amount depends on the least significant figures here. So 0.10 moles. So the final answer will be 0.10, 2 significant figures of NO2. Okay. Question 18 is different than using the ratios. Just simple question. Find the moles of the Cl2 found in 0.71 grams of the Cl2. Of course, here the idea is not sometimes to give you the Cl2, it's given. If they mention here that instead of writing down the formula, if they mention only the name, chlorine, then in this case, you need to know that chlorine is one of the diatomic molecules, and it exists in nature as Cl2. So this is a common mistake done by the students, that they will take the chlorine as only one Cl. In fact, just I want to mention here the diatomic molecules. Diatomic molecules. These are hydrogen. Okay, so hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. Okay, so these are diatomic molecules. In case, for example, I will take any one of these. If they say, for example, chlorine only, or they say chlorine gas, or they say chlorine molecule, any term, we will use only the Cl2, the diatomic. If instead of the chlorine, I write nitrogen, if I say nitrogen, nitrogen gas, or nitrogen molecule, it means it's N2, okay? It's only if I say chlorine atom, then I will take it only as Cl. So this is very important to know the diatomic molecules. So when we say find the moles of the chlorine only, it means it's diatomic, and this will affect the molar mass, whether because it will be Cl2, Cl times 2, okay? So here, find the moles, and the given is the gram. So the mass is given in grams. I can get the molar mass from the periodic table or from the relative atomic mass here. Simple ratio or formula, N is equal to mass over the molar mass. So N is equal to the mass, which is 0.71 grams, over the molar mass. Don't forget here that chlorine is Cl2, and the molar mass for the Cl2 will be 35.5 times 2. So it's 0.71 divided by 71. And then the answer is 0.01. But since the answer the given is two significant figures, then my answer should be two significant figures. So it will be 0.010 moles. And this will be the final answer. Two significant figures. In the last question here, we need to find the moles of the CO2 found in 1.5 times 10 to the power 23 molecules. Of course, we have relation between moles and molecules. We know that every 1 mole contains Avogadro's number of particles. So 6 times 10 to the power 23, whether atoms, whether molecules, okay? So every 1 mole contains 6.02 times 10 to the power 23 molecules, okay? Or particles in general. So we can have, for example, a formula here, or we can just use it by using the ratio. We can know that the number of moles is equal to the number of molecules divided by Avogadro's number. I will solve it in both ways. N is equal to number of molecules divided by Avogadro's number. So to find the number of moles, molecule is 1.5 times 10 to the power 23. Avogadro's number, if we take it as 6.0 times 10 to the power 23, these will be cancelled. 1.5 divided by 6 is 1 over 4, which will be 0.25 moles. And here, if I want to look at the significant figures, here I have two significant figures. And also, in the given, 1.5 is two significant figures. So in this case, the answer will be 0.25 moles. If I want to solve it by using this ratio, it is the same thing, it's easy. Every 1 mole contains Avogadro's number of molecules. 1.5 times 10 to the power 23 molecules will contain how many moles? Simple cross multiplication. 1 times 1.5 is equal to 6.0 times x. So then x is equal to 1 times 1.5 times 10 to the power 23 over 6.0 times 10 to the power 23, which will be the same thing, 0.25 moles, going to two significant figures as the given is two significant figures.
We talk about the chemical reactions and the ratios, how can we solve questions. In the first question, find the volume of the hydrogen at STP needed to react with 3.55 grams of the chlorine. Of course, in order to solve like this question, we need to follow some steps. The first step is, first of all, to select the species that we will work with. And we can see here that we're working with hydrogen, find the volume of the hydrogen. So I want the hydrogen from the reaction. And also I want the chlorine, 3.55 grams of the chlorine. So I want hydrogen, I want chlorine. From the reaction, I will select hydrogen. So below hydrogen, I will just write a line. Below Cl2, chlorine, I will write a line also. So we have ratio of the hydrogen. So this ratio here belongs to hydrogen. This ratio belongs to the Cl2. Okay? So we have ratio for the hydrogen and ratio for the Cl2. I think we need to stop.